is the tutorial for Chapter 3, Section 4, titled Solving Multi-Step Inequalities. And so we solve these just like we would regular old equations, except now we have an inequality sign we have to deal with. So we're first going to use that distributive property. I'm left with 12c minus 15 minus 2c is greater than 0. So I collect some like terms right here. Looking at the signs in front, that gives me 10c minus 15 is greater than 0. And then I go ahead and add the 15 to all sides. And once I'm done with that, I'm left with 10c is greater than 15. So I go ahead and use the equality property of multiplication, which says I can multiply numbers on both sides. And in this case, I'm multiplying by a tenth. And so I'm left with c is greater than 15 tenths. I'll take out that common factor of 5 from both the top and the bottom. I'm left with c is greater than 3 halves. And so that makes 1 1/2. So if I was to graph that, 1 1/2 would go right here. And then number like 2 is larger, number 1 is smaller, and it is greater than, so it's all the numbers larger in this direction. If I use the distributive property on this one, I'm left with 22 is greater than or equal to 10y plus 15 minus 3y. Collecting some like terms leaves me with 7y plus the 15, and that is less than or equal to 22. So I'll go ahead and subtract that 15 from all sides, and what that leaves me with is 7 is greater than or equal to 7y. So when I divide by 7, you can see how 1 is going to be greater than or equal to y. But I like to understand the problem a little better. I like to read from the variable to the numbers. So notice that y, it points to the y, so whenever, and it's open to the 1. So if I move the y on the other side, I need to switch the inequality sign around. So y is less than or equal to 1. So if I was to graph that, it would be a closed circle on the 1. All the values of y are less, going to the left. Well, we also have some problems in which we can have no solution, or we could have infinitely many numbers, which we'll just say is all real numbers could be solutions. So let's take a look at those instances here. So we solve or we use that distributive property. I'm left with 6w plus 5 equals 6w plus 3. So here's where we're going to end up with that. When we go ahead and use that the addition quality property of addition, in this case, adding -6, and that will cancel out the 6w's on both sides, leaving me with a true statement. 5 is greater than 3. So no matter what value of w we put in, we'll always get a true statement. So it's only when all variables cancel, and we have a true statement, that means that we would say we have all real numbers. Numbers are solutions. So that would be the case there. Let's take a look at this other one, though. Oops. So the other one, we use the distributive property again. I'm left with -12 plus, and actually that's going to be a minus, so I'm going to change that right now, minus 2s is less than -16 plus 2s. And so I use the equality properties, moving the s's to one side. So I'm going to end up adding this 2s. And in this case, this is going to give us a one-number answer. So let's go ahead and modify this problem a little bit so we'd end up with something that would be untrue here. And so let me go ahead and change this problem around just a bit at this stage. Let's say it is, let's make this a plus 2 right now. And so I'm going to make that a positive 2, and this will become 12, and then it'll come plus 2s is less than -16 plus 2s. So I wanted to change that because I wanted you to see one where we have no solution. In this case, I'm getting that because you see now when I subtract the 2s's, I cancel out all variables. I'm left with a statement that is false. Negative or positive 12 is not less than -16. So this is a false statement. So again, all variables cancel. We can only use this case if all variables end up canceling out and we don't see any, and we end up with a false statement, then we would say there is no solution. So that's the special case scenarios. Let's take a look at some word problems here. So here we have the same instance. Those are the same problems. Let's go ahead and pull these guys out and take a look at the word problems. And we'll look at this one first, give ourselves a little bit more space. And it says, a grandmother says her grandson is 2 years older than her granddaughter, and that together they are at least, so that helps us out, at least 12 years old. So this tells us our inequality sign. So let's take a look at what they say. Grandmother says grandson is. Is means equals. Okay, so I'm going to write some variables. I don't know what the grandson's age is. So I'm going to say grandson equals S. Granddaughter, we'll say, equals D. So the son is means equals 2 years older than the granddaughter. So I'm going to do D plus 2. So the granddaughter's age plus 2 years. So now it says that together, the son, the grandson, and the granddaughter are at least. At least means greater than or equal to 12 years of age. And so now I've got those two unknowns, but I'm going to substitute in place of not D but S. In place of S, I'm going to put this expression that I have, that the granddaughter is 2 years younger. So I had to add 2 years to the granddaughter's age to make the grandson's age. Plus the granddaughter's age is greater than or equal to 12. So when I collect some like terms, I get 2D plus 2 greater than or equal to 12. So I subtract the 2. That means 2D is greater than or equal to 10. So when I divide by 2, I'm getting D is greater than or equal to 5 years of age. So I know that the granddaughter is greater than or equal to 5 years, and that the grandson, well, if I go ahead and take that 5, stick it in for D right there, that would be greater than or equal to 5 plus 2. So the grandson has to be greater than or equal to 7 years. And so let's take a look at our next problem, and that's what they're asking for. How old are the grandson and granddaughter? And so those would be the answers we'd have there. And let's take a look at the next one. It says a family decides to rent a boat for the day while on vacation. The boat's rental rate is $500 for the first 2 hours, and then $50 for each additional half hour. And so what we're going to end up doing is, it says, suppose the family can spend $700 for the boat. So can spend tells me that it's going to be less than or equal to $700. So they can spend that amount, but they can't spend any more. So that's why I'm using that representation. So we'll start with the boat rental. The boat's rental is $500. So I've got $500 for the first 2 hours, and then $50 for each additional half hour. So it's $50 for each additional half hour. So I'm going to change this. So this is the same thing as saying $100 for each additional hour. So I just changed it so I can change that half hour to just a full hour. So we're going to add on. So we got the $500 for the first 2 hours, and then $100 for each additional hour. And since we've already used 2 hours, I'm going to say H minus 2, because those 2 hours have already been consumed with that $500. So H equals hours rented. And so now we're going to go ahead and write that less than or equal to 700. So I use that distributive property. I've got 500 plus 100H minus 200 is less than or equal to 700. So I go ahead and combine some terms there. That makes 300 plus 100H less than or equal to 700. And then I move that 300 over, subtract it from all sides, and I'm left with that 100H is less than or equal to 400. And so it looks like we'll end up being able to rent that boat for less than or equal to 4 hours. So we could, since we're going to spend $700, or we can spend up to that amount, 4 hours would be the total amount of hours we could rent for $700. If we went less, then it would obviously be less than that. Those are the types of problems you're going to see on tonight's homework. Good luck.